A wind turbine works by converting the kinetic energy of wind into mechanical energy, which is then transformed into electrical energy. Here's how it works. Aerodynamics, lift and drag. Forces. When wind flows over the curved side of the blade, it creates a difference in air pressure. The pressure on the curved side of the blade is lower than on the flat side, generating a lifting force that causes the blades to spin. This lift force is stronger than the drag, enabling the turbine to rotate with minimal friction. Blade pitch control. To optimize performance and protect the turbine, the blades can rotate along their length using a pitch control system. By adjusting the angle of the blades relative to the wind, the system can either maximize energy capture when winds are moderate, or feather the blades to reduce stress in high winds or storms. The blades are mounted on a rotor. The rotor is the rotating part of the turbine that directly transfers the motion of the blades to the turbine's internal machinery. The rotor's rotation is relatively slow, typically about 10 to 25 RPM for large turbines, but even at these speeds, the blades capture significant energy from the wind. Swept area. The area swept by the blades as they rotate determines how much wind energy can be captured. Larger rotors can capture more wind energy because they sweep a larger area. Upwind versus downwind designs. Most turbines are designed so that the blades face the wind. Some turbines, however, allow the wind to pass through the rotor before reaching the blades. Upwind designs are more common because they minimize turbulence from the tower that could affect blade performance. The rotor turns a low-speed shaft that runs into the gearbox located inside the nacelle. The gearbox is essential because the rotational speed of the rotor is too slow to generate electricity efficiently. Gearbox. Function. The gearbox uses a series of gears to increase the speed of rotation from the low-speed shaft to a high-speed shaft. It typically multiplies the rotor speed by 40 to 100 times, depending on the turbine design. For example, if the rotor is spinning at 15 RPM, the gearbox might increase the output shaft speed to 1,500 RPM, which is ideal for the generator. Direct drive turbines. Some modern turbines skip the gearbox entirely and use a direct drive generator which directly converts the rotor's low-speed motion into electricity. These turbines are simpler, have fewer moving parts, and require less maintenance, but are generally more expensive due to the specialized generators required. Electromagnetic induction. Inside the generator, coils of wire are fixed while a rotating magnet spins inside them. As the magnet spins, it creates a moving magnetic field that induces a current in the stator, producing electricity. Types of generators. Most turbines use either synchronous generators or asynchronous generators. Synchronous generators produce electricity at a constant frequency, while asynchronous generators allow for variable speeds. In large wind farms, the choice depends on the grid requirements and turbine design. Before the electricity can be sent to the grid, it must be processed by a power electronics system to ensure that the power is compatible with the grid's voltage and frequency. Most modern turbines use sophisticated control systems to regulate the power output and adjust the turbine's operation in real time. Inverters and rectifiers. If the turbine uses variable speed generators, the control system may include an inverter or rectifier to convert the varying output into a steady stream of alternating current electricity. Grid. Synchronization. The control system also ensures that the electricity produced matches the frequency and phase of the grid. This is crucial for safely feeding electricity into the grid. After being processed by the turbine's control system, the electricity is typically at a low voltage. It is sent to a transformer, either inside the nacelle or at the base of the turbine tower, which steps up the voltage to a higher level. This higher voltage is necessary to reduce energy losses during transmission over long distances. The high-voltage electricity is transmitted from the transformer to a substation where it is fed into the electrical grid. From there, it is distributed to homes, businesses, and other consumers. Wind turbines often operate in wind farms, where many turbines are connected together, and the combined output is sent to the grid. Wind turbines are complex machines designed to efficiently harness wind energy and convert it into usable electricity. By using aerodynamic blades, gearboxes, generators, and advanced control systems, turbines can produce clean, renewable energy without emitting greenhouse gases. If you enjoyed the video, give it a thumbs up, comment, and share it with your friends. Don't forget to subscribe to our channel and hit the bell so you never miss a new video.